All right, I'm very excited. It's time to start modeling. It's time to start using machine learning to figure out whether or not we can classify whether someone has heart disease or not based on their health parameters. So in previous video, we said that we're going to try out 3 machine learning models. So we'll put them out here. We're going to try 3 different machine learning models. 1, logistic regression. 2, k-nearest neighbors classifier. And 3, random forest classifier. And if you're wondering how we came about these 3, it's because we went through this diagram, the scikit-learn machine learning map. If we followed this through based on our data, we came across here. A good question you might be asking is, hey, I don't see logistic regression. We kind of covered that before where it said logistic regression, that doesn't really make sense. It's got regression here, so we're not trying to predict a number. We're trying to predict a category. Why are we using it for classification? And I was pretty stumped too when I found out that we could use logistic regression for classification. You might be thinking even further back, how did you even find logistic regression if it's not in here? Well, I was a bit confused at this too. I was wondering, why isn't logistic regression listed here? But after searching, if we go sklearn logistic regression, and you might be wondering, what if I didn't even know to search for sklearn logistic regression? Well, the way I stumbled upon this is I just went machine learning models used for classification problems. I searched something like that, and then someone suggested logistic regression. And so I decided to search logistic regression, and I found it in here, scikit-learn. It had an implementation. I could, of course, build it from scratch, but I'm more of a practitioner, right? I want to apply models that someone else has built in the past. So, and then I read through, and maybe it wasn't in this, logistic regression. Maybe it was in the user guide. That's, I think, where it was. So logistic regression, here we go. Despite its name, is a linear model for classification rather than regression. So this line here kind of clarifies the confusion in the name being logistic regression. And of course, you could read through all this. You got some math here of how it's actually implemented. But the reason why we're trying it is because we're pretending that we've tried linear SVC. We actually have in a previous scikit-learn video. I'm going to say that it's not working. So now we're trying, we've gone through here, we're not working with text data. We're going to try k-nearest neighbors classifier and ensemble classifier. So that's how we've deduced these 3 different models. And why logistic regression? Well, I've decided to throw it in here because it's not listed there. And we want to kind of check it out, because if it's not on the standard list of algorithms to try, we might try and figure it out anyway. And again, if this process seems like it's not really structured at all, it's like, where did Daniel find that machine learning model? What did he even think of? Again, it's just from searching something like this. Once we've defined that our problem is classification, if you're trying to figure out which machine learning model that you want to use, it's something as simple as this. And you could search for it and explore. And if we go back to our keynote here, that's what we're doing. We're up to experiments. We're trying different machine learning models. But that's enough talking. Actually, one more thing, and that's what I want to try and encourage you to do, right? Is that because there's so many different ways to do things in machine learning, a lot of it is about just searching for the answer, or not even the answer, just asking questions and trying to implement them. That's what we're going to do now. So, because we want to build 3 different models, and because we want to evaluate them, and because we want to do a couple of experiments to see which one is the best, we want to train them on the training data and test them on the test data, evaluate them. What we might do is set up a little dictionary with our models in it, and then we'll create a function to fit and score our models. So rather than rewrite all the same code for fitting and evaluating our models, we'll set it up in a function. Yeah, that's a good idea, Daniel. Let's do that. All right. So put models in a dictionary. We're going to go models equals logistic regression. And we're going to go here. And this is logistic regression. And then we want to go KNN. We're going to instantiate the class here. So it's going to be K neighbors. We can probably place tab autocomplete, let's be real. And then we're going to go here, random forest. And this is going to be our trusty random forest classifier. Beautiful. And then let's go create a function. We want to fit and score the model. So we want to train it. We need a function to train our models in the training data and then evaluate them on the test data to fit and score models. So def fit and score, something simple. It'll need to take our dictionary of models, and then we'll take xtrain, xtest, ytrain, ytest, and we could put a little doc string here just to make sure our code is legible. If someone else was to use this function, what would it do? So fits and evaluates given machine learning models, and then we'll tell it what parameters we're using. So models, a dict of different scikit-learn machine learning models. What's xtrain? We know what xtrain is. Training data, no labels. Xtest is testing data, no labels. And then ytrain is training labels. And then ytest is test labels. Beautiful. And now what should we do? We might set a random seed. Set random seed even if it's within the function to make sure that our results are reproducible. And then we're going to go here. We'll make a list to keep model scores. Or actually, this is probably better. Make a dictionary. That's what we want because we're working with dictionaries here. We want to go model scores equals an empty dictionary because we're going to fill it up in a second. We'll talk through this function as we do it. So loop through models. So this is where we're going to go for name model. So name is the key. Model is the value of our dictionary. So for key value in models.items. So we're accessing the items of a dictionary with .items. And then we're going to go fit the model to the data. This is where we go model.fit xtrain ytrain. So we're fitting our model there. So for each model, it's going to fit it to the training data. And then we want to evaluate the model and append its score to model scores. So this is how we're going to evaluate each model in one hit. We're going to save the name of it to our dictionary here as the key, and then its score as the value in model scores. So model scores name. So we're creating a key in the model scores empty dictionary, and then we're going to go equals model.score. So this is our model here. So for example, if it was logistic regression, we've just fit it. So logistic regression.fit xtrain ytrain, and now we're appending logistic regression.score xtest ytest to model scores under the name logistic regression. And if we're going through that and you're thinking, whoa, that's a fair few steps, it's only about 2 or 3, but that's all right. When I first worked with these kind of functions, I was like, hold on, I'm used to just doing this line by line. But we're being efficient in this project. So we're going to return model scores, which will return a dictionary. So we'll hit Shift and Enter. And I wonder if this will work. So basically what it's going to do is it's going to take our dictionary of models. It's going to set up a random seed. It'll set up an empty dictionary. Then it's going to loop through our models dictionary. So for name model, so for logistic regression in models.items, logistic regression, we'll pretend it's logistic regression, .fit, so it's telling the logistic regression model to find the patterns in the training data. And then it's going to create a key in our empty dictionary model scores with the score of how well our logistic regression model performs on the test data, aka using the patterns that it's found in the training data. And then it's going to return our model scores dictionary. And then we're going to see how each of our model performs on the test data set. And our 3 models here, we should have 3 different scores. So we're going to leave it on a cliffhanger there, and we're going to evaluate our 3 models in the next video. So I'll see you there.